All right, guys. Let's get started. Okay. So let's get started real quick. Can you guys see my screen? Okay, great. So now we're moving into the cloud. You know, this is where we are getting closer to what understanding the concept of what being a DevOps engineer is. So basically, so we're moving from local development to real production infrastructure. So we're going to understand what we build and why before, you know, getting into um the hands-on with the AWS cloud. So why are we doing this manual cloud deployments? We already did the local deployments and we understand basic networking and all the rest of it. Just okay, port 5,000 for the Flax backend, then front end to hard zone, we access it through local host and all the rest of it. So now the whole point is to understand all these things, yeah, before we start going into automation, right? So automation without understanding leads to fragile, difficult to debug systems. So this stage is about building a strong foundation. So we're going to be learning network fundamentals, like we're going to understand and grasp these PCs. You'll see it's being created, subnets, we'll see routing table and internet gateways. We'll understand the security boundaries, we'll understand IAM, you understand roles, users, security groups, access control, and learn how services interact and perform in a live environment. So everything we automate later from infrastructure as code to CI/CD is built upon this essential understanding. So that actually says everything. All these manual things we're doing right now is going to build up and make us understand how to, properly um automate our infrastructure, whether it's our infrastructure and configure it properly. So whether it is from IAC, which is infrastructure as code, or CI/CD, which is continuous integration and continuous deployment, we would understand that. So if you don't understand manual cloud deployment, Terraform and Kubernetes will feel like magic. And yeah, magic bricks. So our application consists of three core components, like we already have established here, and each of them with unique characteristics and deployment requirements that must be carefully considered. Yeah. So for our front end, which is React based, we have static files that will be delivered globally through a CDN, which is content delivery network. for optimal performance and user experience. So this is modern way of we're going to see both ways at which we can deploy the front end on an EC2 instance and also using CDN, yeah, which is CloudFront and um and all, yeah, CloudFront, S3 buckets and all that. So our backend, the Flask API, it's a long running service. Can you guys hear me? So, all right, great. So our backend has to be a long running service handling business logic, requiring scalable compute resources and efficient process management. So you see the way we ran it on the local, yeah, that we just did run um run pi. You understand? Remember, we just did a very simple run Python or something like that, right? And the backend came up, right? It's for our production or a development environment in the cloud and all that will need constant processing. We would deploy this in a very different manner. We're going to deploy it as a service. Then database, so stateful data persistence, demanding high availability, robust backup strategies, and strong integrity guarantees. So secure communication between all components is paramount, necessitating careful configuration of networking and access control. So your key takeaway should be from this should be different components have different, deployment needs, influencing our architecture choices and manual setup steps. So what changes when we move to the cloud? In our local environments, like I said, we're just running directly. I know everything runs on local hosts, no real network boundaries. We didn't really touch proper networking and all that. We're just working on local host. Security is implicit or assumed, you get and all that. So, but for cloud environments, we have real networks. We have the VPC where we'll play with CIDR blocks, assign the amounts of IPs we need, subnets, breaking it down. We have route tables, explicit security rules. We have IAM. We're going to touch on IAM. We're going to see how to create users, how to create roles. You understand? How to create a security group. Then we have public versus private access and all, which is very critical. Failure becomes real and tangible possibilities. So the cloud will just force us to be explicit and intentional about every aspect of our infrastructure and application. So the cloud networking mental model. So before deploying any application, we must first establish a robust, secure network foundation in the cloud. Everything resides within a network. Hmm? So making its design very paramount. Yeah. So we're going to be creating a VPC, which is our isolated um virtual network in the cloud, fully under your control. Yeah. So then subnets, it's logical divisions of within our VPC for organizing um resources and defining traffic flow. So I'm pretty sure by now you guys understand that because we've touched on VPC and subnets briefly before. Then we have security groups, these are virtual firewalls controlling inbound and outbound traffics for instances at the network interface level. and it's for the EC2 instances. So it's in the subnet actually. The internet gateway enables communication between VPC and public internet. So what is a VPC? A VPC is a virtual private cloud in your own isolated virtual network within AWS. And it's designed to function much like your own on-premise data center. If you know what an on-premise data center is, when you guys are hosting your own bare metals and all the rest of it in your own maybe in your offices and all the rest of it, you get. But this one is within AWS, so that's what is called a virtual private cloud. Yeah. So it's within AWS's own infrastructure. So it grants you complete control over your network environment. You define your own IP address ranges and subnets. You control network access policies, dictating who can communicate with whom. Yeah. So it also determines which resources are publicly accessible and which remains private. So all these things we're going to understand now when we're deploying our infrastructure and our application. So public subnets versus private subnets. So subnets allow us to logically partition our VPC into smaller, more manageable networks. So understanding that distinction is crucial for network security and application architecture, just like what we've been saying. Understanding how all this breaks down is necessary, and for cloud security and application architecture, we know what goes into the public subnets, what goes into the private subnets. So for the public subnets here, as this one has direct internet access, and that's via the internet gateway. Yeah. And it's used for resources that need to be reachable from the internet, like our front end, our load balancers and public facing APIs. All those ones can be hosted on a public subnet. Then the private subnet is obviously the opposite, with no direct internet access, and traffic routes through a NAT gateway for outbound internet access if needed. So if it is needed that the application can reach the internet, but not the internet reaching it, we'll use a NAT gateway to provide that access for whatever lives in the private subnet. Then this houses resources that should remain isolated from the public, like our databases, internal services and microservices that you use within the company, and application servers like the backend. Although we're going to be deploying our own application server in this one in the public subnet. So for maximum security, databases and sensitive internal services should always reside in private subnets, never directly expose them to the internet. Then security groups acts as virtual firewalls for your Amazon EC2 instances. It controls both inbound and outbound traffic. They are stateful, meaning if you allow an inbound request, the outbound reply is automatically allowed. Do you understand? So you allow an inbound request, it will definitely communicate back out, because it has been registered that, okay, this port is open for this. Do you get? So a crucial principle for security group is that they operate in an allow-only basis. You explicitly define what traffic is permitted, and everything else is implicitly denied. So you can't deny on this one. So it's only just to allow. And the network ACL, you'll be able to do allow and deny and all. But for the scope that we're working with security groups, and it's only on allow basis. So for granular control, security groups allow you to specify fine-grained rules based on ports, protocols, source destination. And so just for example, allow inbound traffic on port 5000 for HTTP and HTTPS from maybe the load balancer security group only. Yeah. And database instance, you only allow inbound traffic on port 5432, which is the Postgres own ports, exclusively maybe from the backend API server all the time. So just ensuring isolation. Then there's something called a Bastion host, which allows you to access um the Bastion host allows you to access private resources, you know, private resources through SSHing, right? So when you put things in like maybe your private subnet, like maybe your Postgres or your backend is right there, you would need to be able to communicate with this. So you would now allow you create a bash something called a Bastion host. So what that Bastion host is an instance that you can SSH into, yeah, to access the resources in the private network. And why that's possible is because the Bastion host is going to be publicly available, but you're going to map the SSH ports to only allowed IPs. So that hardens the security. So nothing can reach the private resources unless they get into the Bastion host. So our architecture, what do you mean by jump servers? I would not I do not I've not used jump servers. I'm talking about SSH. You SSH into your Bastion nodes and you access your private resources. So I've never worked with anything called jump servers. Let me check what the jump server is right now. So this is sounding more like a Bastion host itself. Well, that's what the Bastion host is. So I don't know why it would use a jump server to access a Bastion host. But that's the basic it might just be naming conventions and all that that is happening here. But they sound like they do the same thing. Anyways, our architecture is front end. We're going to be serving it through CloudFront and S3. The application tier is going to be on an EC2 instance and handles like the basic the business logic. And we have a private database, the Postgres SQL, in a private subnet with no internet access. So that's basically what we're going to be creating today. Yeah. By now we all should know what an EC2 is. So it's just Amazon Elastic Compute Cloud, short form EC2. So it's fundamental to AWS. It provides a sizable compute capacity in the cloud. So it's giving you a server where you can, run your computes and all the rest of it. So it's a virtual server allowing you to run applications without managing physical hardwares. So you don't need like on-prem servers and all the rest of it. So Yeah, we are going to be responsible for the OS updates and patching. So that's like, installing necessary um packages and updating and upgrading them, all that. So system level security configurations too, installing and managing management of application runtime environments, So we're the ones that will install all those by ourselves and also scaling our application. So an EC2 is not Docker, yeah, and it's not Kubernetes. So in production, in production, backend has a way that it should run. Yeah. It has to be reliable, resilient. Yeah. And it's far beyond simply launching a script from the terminal, just the way we do it. Well, just the way we did it in locally. Yeah. Yeah, EC2 is virtual machine in Azure. So we're running our backend directly from an SSH session or a shell script will really cause serious failure. So it's a common pitfall that leads to fragile and unmanageable systems. When the SSH section disconnects or the terminal closes, the application dies with it. Yeah. So, and that will leave our users without service. So in production, we want it to start on boot. We want it to restart itself on failure, and we want it to be logging consistently, right? So, and what all those ones may start on boot is that the application starts when the server power is on. You get once if maybe you reload it, reload the server and all the rest of it because you want cleared memory or whatever it is. Once the server starts up, the application starts up. So if it fails, also if it crashes, it will restart itself. Yeah, and it logs properly. It produces structured logging and consistent logs to a destination, to a particular designated location. So we can monitor, debug, and audit. And what we're going to be using to achieve that is called G Unicorn. So it's Green Unicorn. It's for Python. It's an HTTP server for Python applications. Yeah. And we're going to also be using systemd. So systemd system is a system and server service manager for Linux operating system. We've most likely seen that happen when we check processes with systemctl status, and all. So we use journalctl to also check the logs for the application. So our database deployment, we can decide to use EC2 where we'll have full control and full responsibilities and all the rest of it. We'll deploying the database directly on the EC2 instance, provide ultimate control over the operating system and database software. But it comes with significant responsibilities that I already mentioned, which is full control and full responsibilities. Then we also have managed database, which is called RDS, Amazon Relational Database Services. And that offers managed database instances, abstracting away all the online infrastructure. So we're not going to be having full control or full responsibility, and it's safer and production ready. So we're going to be using that to create our manual deployment just to see how to also create so you can have the skill of creating an RDS um um AWS. So that will be one of your skill sets and all that. We've seen database on our local, so it's similar to that. So if you run the installation and the client, the installation package, and also for the client also you get, and you run your PSQL commands and all that. So this is why database deserves extra care. So database, they are the heart of nearly every application, storing vital information that drives business operations. Unlike other components, their unique characteristics demand a heightened level of attention and robust management. So it houses you know, the most vital thing of the application, which is the data. You understand? So it's stateful. It retains states, meaning that their current condition depends on past operation. It's keeping tabs of everything. Yeah. Makes them inherently more complex to manage and scale than stateless services, right? So this is a whole, there's some people that are data engineers and and data analysts and data scientists. Majorly, they deal with all this databases and all. So, but we also do a little bit of works with data, migrating data and all the rest of it. So hard to migrate, moving or changing databases is a significant undertaking, often requiring extensive planning, downtime, and rigorous validations to ensure data integrity. So that actually is real true, because I can remember there was a time where we were moving environments, so we were migrating our environments. Any little mistake with the volumes of the database can actually result into catastrophe, serious catastrophe. And so we have to be very careful with it, because data loss is also equal to business failure. If the loss or corruption of database data can have catastrophic consequences, leading to financial losses, reputational damage, and even legal repercussions. So, everybody is always about this data privacy and all the rest of it. So that's why the database is actually very, very, very vital and a crucial application that needs to be protected properly. So, and we don't want loss of data. If not, that's going to be very bad for business. So data is always private, it's backed up, and has access control enforced. So front end not equal to back end deployment. You should have that in mind. We are going to build static files, and it's going to be built once and saved everywhere around the world from a CDN. Then backend, remember, long processing, it has to restart on failure, it has to start when the system starts, and it has to log. So manages authentication and authorization, handles application logic. So front-end assets being static do not require dedicated servers to run, unlike dynamic backend services. So, but if your front end is dynamic, you really will need if you're having dynamic front ends, you would actually need to use maybe something like Amplify, or run it on an EC2 instance also. So while we use S3 for front-end hosting, we don't use servers. So we eliminate the need to provision, manage, or patch servers, simplifying operations and reducing maintenance overhead for our static files. It's cost effective. You pay only for the storage data transfers you use. and that's quite cheap on S3, right? And it scales automatically. S3 is designed for massive scale, effortlessly handling millions of requests and petabytes of data without any manual intervention or capacity planning. So that's one of the reasons why we are going to be using S3 because it scales heavily, very effortlessly, and it's secure too by design. So our initial cloud deployment, you know, we're going to adopt a hands-on manual approach for better understanding, you know. So we'll build the front end on our laptop in the repository. We'll do a manual file upload, and it's going to be human driven development, and we'll have our local AWS credentials, right? Then we're going to also work on DNS. So because we don't want to have ugly looking ugly looking IPs that and all the rest of it and DNS that aren't fine-tuned, as it's supposed to be in production. So we're going to be using DNS to create subdomains where our applications will live. So the end-to-end flow would design the network, will provision EC2, deploy the database securely, deploy backend as a service, we deploy front end as static files, then hard DNS and HTTPS. So that's TLS certificate to enable secure user-friendly access, just like what we're seeing right here. We're seeing this is actually secured. So what comes after this stage is going to be automated version and reproducible. All right, let's get into it. Or do you guys have any questions first, or we should just run along? All right, run along since nobody responded. All right. Yeah, the material is going to be uploaded to the LMS later. I'm going to have access to it later. Okay, so well, what do we do now? Oh, I forgot. I have to share my screen. What changes are yet to be pushed to the repo? All right, so we're in the cloud. So we're going to design a clear, secure, production ready network. So what we're going to understand, we basically understand the infrastructure and the architecture of this particular application, right? So we're going to create our own VPC. We're going to give it our IP address ranges, which machine talks to which one. So let's begin. There's going to be VPC and more. Most of them are actually what do you call it? Easy to generate. So we're going to call this tax app VPC. So we'll leave the IP, the CIDR block IP range as this. And we'll leave it as the tenancy as default. If we want to read some information, you can run instances on your VPC on a single tenant, dedicated hardware software. So I advise you guys read this, understand it. So we're going to be using two availability zones just to understand properly what's, you know, a private subnet and a public subnet is. For this particular application, we literally don't need two, but just for high availability understanding, yeah. In case one availability zone crashes, the other one will still be up and running. That's the reason why we use multiple AZs. Yeah. Then we just create our VPC. VPC is not security. VPC is networking. You're creating networks. Yeah. Yeah, the networking is going to be secure, but you understand, it's for networking. That's where we have our subnets. That's as you can see. We have the subnets here. Hmm? We have the internet gateway. We have the route table. So it's for networking. Yeah. Okay, so we've created this. We have internet gateways. We have the route table. And now we're going to have to create our security groups. Yeah. And fix our inbound and outbound rules for them. Hmm? Shall we begin? So we go to EC2. Excuse me. So creating our security group, we'll name the security group. Sorry, give me a moment to arrange this properly. So we'll name the security group. This is going to be tax app front end SG. So description, obviously we need access on port 80. What? Can you imagine that? Select the VPC. Then we're going to add an inbound rule, which is going to be HTTP and HTTPS. So whatever it is that is in this particular security group, which is going to be housing our front end server. So we're going to be deploying our front end using S3 buckets. Remember that though, but I'm just showing you how to create so we would not actually need this front end SG in proper sense of it. So you must put it from anywhere in the world, from anywhere. So all IP addresses can reach this, right? So it's going to tell you we recommend certain security group rules to more restrictive and to allow traffic to specific known addresses. But we want everybody in the world to reach this our particular front end, right? So we create that. Then we're going to create another security group again, which is going to be for the back end. So ideally, this is only supposed to allow the front end SG group. So we're going to do that also. Remember, you have to select your VPC. If you don't, it's going to be on another network, and that's going to cause a whole lot of networking problem. The SSH from my IP. Then we will have I said front end 5,000. So it's custom TCP 5,000. We're going to have that from this is going to provide an error that we're going to see and have an idea on how to debug properly down the line. Then we're going to have create the other last security group. So we have so inbound rule Postgres, and this should be coming from. So remember, only the backend should be able to communicate with the private database, right? So that's all we're going to be allowing. So now that we've created all the security groups, right? So from the internet, it's reached the internet gateway, it's reached the public subnets, then from public subnets, the front end can be reached, yeah? And the back end also can be reached. But we did not set it that way. We want the front end to actually communicate with the back end. We'll edit all these things going forward. Then private subnet, only the back end communicates with the front end. Remember that, right? So we can temporarily open what do you call it? The back end to accept from the entire internet, so it will be also accessible. But I want to simulate something going forward. So common pitfalls you should understand about this, yeah. Don't put all your resources in the public subnet. That is a very bad thing. And don't make your security group over permissible. Don't make it permissive. Don't, allow traffic. You saw that warning that was given that you have to select particular IPs that should be accessing this, yeah? So also pay very good attention to your outbound, because if it's not going out, it wouldn't really work properly, yeah? So remember SGs and stateful SHA and all that. So now let's move on to provisioning an EC2 instance. So we're going to be provisioning two EC2 instances, one for the front end and one for the back end, right? So you should understand something called AMI, which is Amazon Machine Image, and so it's an OS template here. It's when maybe you're when you're having like VirtualBox and all, and you want to install an OS, that you download Ubuntu and all that kind of stuff. So that's what an AMI is. It's called Amazon Machine Image. Excuse me. So it determines the package manager, the default users, yeah, and the file system layout. And this is what it is here. You can use Amazon Linux, we have Mac OS, we have Ubuntu, which we're going to be using. Windows server, you can get a Red Hat server, a SUSE Linux, a Debian. There are quite a lot still. And you can also browse more AMIs. So we name our server. You can see the description we're using the Ubuntu server. We're going to be using T3 micro. Because it is free tier available. Yeah, that's why we're using it. And it can handle the application that we want to use. So that's good enough. Then you would have to create a new key pair. You name your key pair. So this is what enables you to SSH have a proper SSH handshake from your local to your cloud environment. So you can choose between RSA and ED25519. So let's call this tax. So what happens is it's going to download the private um this thing for us. So yeah, it is. So we're going to access this. You're going to make sure you're able to access this. They're just different formats. You can Google to understand more. They're just different formats. Make sure your key pair is accessible, properly accessible. So ideally, it's supposed to be in your the SSH. Hmm? So we're going to check that. So we can see our tax app hem. Check the you have check the long list for the tax app. No, this one. Little tax app here. Okay, I mean this thing. LS L. And you can see it is very permissive. So we have to change the permission to only be writable by the user and not by the group and others, right? So that's going to be chmod 400. So we've changed it. So now we'll be able to create um a proper connection when this instance is created. So we select from our security group and type the tax. Why is it not showing? Oh, now thank God that even happened. You have to change your VPC because if we had created this would be on a totally different VPC, right? And you have to enable your public IP because this is backend and we want it to be accessible. Yeah. So Then we select the security group we created. So you can take a look at the advanced networking, but this is quite advanced for your stage right now. Then just to get you guys to understand something. So this user data here, you can actually give it, you can write your maybe your bash script here to configure your system on boot. So it's while it's booting it to now run those commands, maybe install whatever it is that you want to install, but we're going to be doing all these things manually first. So let's launch this. So you wait for it to initialize properly. Let's create Taxap FE. Select the same Ubuntu AMI. Leave it as T2 micro. Select Taxap. Our network settings. We select our Taxap VPC. So this is our backend. It's going to be in the public subnet. This is our front end, sorry. So it's going to be in a public subnet. We want it reachable. Select this. And you're saying instead of creating the security group separately and then launching the instance one after the other, you create the security group with launching of those instances. It's your choice, really, it's your choice, but this is the structure that I prefer to follow. It's best practice, to be honest. Your you create your networking first before you start creating your um EC2 instances, before you start creating your server. It's absolutely your choice. All right. There might be some kind of hiccup with the first one that we created. So this one is already accessible. Let's see. You go through it. This one is in a private subnet. That might be a problem. Let's see if we can SSH into it. So SSH I. You see, it's going to be different. You're going to be using the flag I because of Amazon. You have to mention your you have to tag your key. Did I select backend for the front end? Apologies. That was human mistake. Now you see what is happening right here is why we need automation. Do you get human errors? So I'm glad it is actually happening. I'm glad it's actually happening. So let's just first terminate these things and do them properly. I'm glad this is happening, to be honest. So we are now seeing the reason why we would need um why automation is actually a lifesaver and avoiding human errors. You move with the times, you learn it. So I'm going to be moving quick with these ones. So for front end, I don't know why this thing always does this. Select our key pair, tax app, our network, change our VPC, enable, select existing ones. So front end for front end, I believe everything is in place. Launch the instance. Let's launch the backend instance. While it is loading, takes a while. Remember your VPC created. Did I change? I didn't change it again for that one. Oh my God. Oh my God. That's so sad. Okay, so cross check. We need this to be enabled. You have to select existing ones. This is front, this is backend. So you select your backend security group. The volume is enough. Let me recheck again. Backend Ubuntu, T3 Micro, TaxApp VPC, public subnets 1, EU West 1, enable public IP, selected the TaxApp DB. God of mercy. I so hate manual. I so hate this manual thing, eh? I so hate this manual thing. Don't be lost. It's just human error that is happening, innocent. It's human error that is literally happening in your eyes, in front of your eyes right now. You know, if this was automated, we'll just write all these things down um in code and just run it. So don't be lost. We're just trying to create an EC2 instance, a server. Yes, that's when IAC comes into place, infrastructure as code. Okay, we've implemented this. Takes a while for all this to clear out, so we still have to terminate this one because it's still going to be in the private subnet, and that is FE, and that's supposed to be in a public subnet. Your internet is kind of slow. All right, let's create a new one. Name it tax app FE. I don't know why this is hanging. These are the frustrations that cause human errors too, to be honest. And we are prone to forget. So that's why infrastructure as a code, having provisioning and configuring done properly by code is the best thing. So this is front end, right? So we choose front end. Yeah. So cross check again, so everything will be fine. We're using Ubuntu server, T3 Micro, TaxApp Keepier, TaxApp VPC, public subnet 1, security group, taxap FESG. So we're good. All right, so now I believe we can actually do this now. This is how to SSH into a server. I'm pretty sure you guys understand what this is, right? We've seen this before. No, not necessarily. Why? Why am I sudoing? All right, then you press your enter. It will ask you a question. You say yes. Then we are in the public VP public EC2 for the backend server. So we do. So what we're going to do first is patch properly. We usually use sudo. Is your that's weird though. That's quite weird. All right, we can check all the Linux commands, or my Ubuntu host name. There we go. Uptime. So all those commands we learned, we can use them. It's a Linux server. It's an Ubuntu server. Yeah. So that's good. So now we're going to install build the essential things, the baseline toolings. Yeah. So all these codes will be provided to you guys. Just know that. So important things to do, you have to remove password authentication and remove root login. So and how we do that is through the SSH. So you sudo nano and SSH, remember, lives in etc. So we're going to look for password authentication. Man, I should have used this thing. Vim would be better. So when I want to delete things real quick, I like using Nano. When I want to search and properly use an editor, I use Vim. That's my preference. You guys will decide what works for you. So I can just quickly slash and search password. All right. We have it here. So you can see password authentication is yes. We have to turn that into a no. And uncomment it. It is like hardening the SSH, you know, security and all. Then let's search for permits. No, that's the capital letter, I guess. Permits. Root. Okay. This is quite different. All right, but always make sure root login isn't set. Whoa, because that would actually cause problems down the line. So systemctl restart. All right, great. So we're good with that. Please always remember that you have to change the permission of your SSH key to not be permissive, just chmod 400. So now we are going to we're going to make decisions on how to run our Postgres in the cloud. So, and we're going to be using a managed service, obviously. So we're going to be using a managed service. So my system is hanging. It's quite sad. Right. So we're going to be using RDS. So deploying a database is not just to install Postgres, We have decided where the database will run. We've already decided who can access it. So now we're going to see manually how the schemas will be added. We can also decide how the data wouldn't be lost. So we're going to install Postgres. We're not going to be using Easy Create. We only have single AZ available to us. So our database identifier, we're going to change it All right, so we're going to save this password somewhere. Then I'm going to pin this here just for this class. DB name too should be saved somewhere. You have to save it somewhere. We're going to be using it the T4G micro. It's also free tier enabled. It's going to be a general purpose SSD. So we're not connecting to any EC2 compute resource for this. Then we're going to select our VPC. This one doesn't. Public access, nope. Choose the DB subnet group. DB subnet group. Why is it not showing here? Our subnets are not showing. And we have 4 subnets. Yeah, we're supposed to select the private subnet for this DB, but this isn't showing. Why are you saying I should create? Okay, create new DB subnet group. Why? All right, no public side, no public access. Choose existing VPC security group. We're going to be choosing the DB security group and removing the default. Okay, our availability zone right here. We're not creating any RDS proxy. Always a good idea to tag. All right, looks like everything is good. We still have to go cross-check because, this is human-based. Let's see everything we've created. Full configuration. Postgres 17. Free tier. One AZ, which is availability zone. DB instance identifier, TaxApp TS Academy, the master username, TaxApp admin, self-managed. We created a password. We use password authentication, T4G micro, general purpose SSD. We selected our tax app, VPC, but we're able to select a DB subnet group, which is a little weird, but we're able to select our SG. All right, we're good to start. You have to be very careful, creating your database. So this is going to take a while to create. Cancel. So security group DB only allows inbound rules from our backend app. So we're going to test it out. Hmm? We are going to test it out. So we're going to wait a couple of minutes for this um to finish creating. It's going to take like about 10 minutes, 10 minutes plus. So give me a moment. Thanks. All right. So while this is creating, if you guys have any questions, let's run it through. Questions on everything we've been doing for now. All right, progressive.
All right, a very good afternoon to you,
Data.
Durala. All right, the question I have to ask you is I've been following through on your teachings here, and some of the words and some of all these things, I don't really understand their meaning, but I knew the words like some of the things that you've created so far, I don't understand. So, what's
What was what? I can't hear you again. Oh. If you're talking, I can't hear you anymore. Can you type your message because I can't hear you anymore? I don't know if any other person is hearing you. And for Precious, do you mean inbound and outbound rules? Okay. So for inbound rules, like we said, they are for the security group that is stateful. So inbound rules actually is just telling your security group to allow this particular ports, you understand? Allow this particular ports to be open so we can communicate properly, you get, with whatever is inside this security group. Outbound is okay. Outbound always has itself open to all traffic. So whatever it is that's as an inbound connection can have an outbound, would have an outbound reply. How can we create this free account on AWS? By signing up on AWS. So you just go to AWS website and sign up. You'll get the account. Let's see if this creation has finished. It's backing up right now. So any other question? Is that all? So everybody's good where we are. All right now. All right, Ahmed. Unmute yourself and let's hear what you have to say.
Hi, good afternoon.
Hey, good afternoon. What's up?
This about the last class, the Wednesday class. I don't.
No last class questions just yet. Please, let's focus on
Okay,
this.
okay.
Yeah?
All right then. All right then.
And I've asked out last class questions outside the class. So the
Okay.
videos for people who watch wouldn't have to, you understand? That's to be,
Okay.
yeah.
Oh,
Thank you.
I understand. Thank you very much.
So any other questions concerning what we've learned this class? Okay, this thing is taking so long. Sorry about that. So our application has a new twist to it. The front end has its own repository right now, and backend also has its own repository. So this is backend repository, and this is what we're going to be working with. And this is the front end repository. This is still backing up. Hey, Nicholas, what's up? Unmute yourself.
Yeah, good afternoon.
Good afternoon.
Yeah, I'm so sorry. I kind of joined you guys not kind of late.
What?
I said I kind of joined you guys late, so you already created a VPC already. But I'm getting to understand now that you actually provision one subnet. So I want to really understand how possible is that you have to, install your database, your backend application in a public subnet. Because I was thinking at least you should create a private and a public, and possibly you can host your Bastion host on your public to be facing the internet while you keep your database, your backend safe in the private software. So I want to understand the configuration, how possible this one question of subnet is in terms of hosting this Trinity application.
I'm sorry, I didn't hear you clearly, but I think you're saying the backend is supposed to be on the private subnet. Well, the backend can be on the private subnet and can also be in the public subnet. But your inbound rules of your security group and your and all would actually determine what can reach it, right? So that I created both private and public subnets. Our DB is going to be living in a private subnet, right? Only the backend service will be able to reach it. Yeah. So you get only the back end service will be able to reach the DB, and the back end will also be able to communicate and be reached by the front end security group. Do you understand? And that those ones live in the public subnets, but the back end is a little bit much more private than the front end. So that's the architecture that we're following. So if you have if you have IP addresses that are public, yeah, like public API, sorry. If you have a public API that you exposed, that's when you put your what do you call it, your backend in the public subnets. You understand? It puts part of the services in the public subnet and all that. So when anything gets more complicated, where you have some places that some APIs that are private and some that are public, then and you're working with microservices, you can now decide all those kind of things. Okay, put this one in a public subnet, put this one in a private subnet. But now our backend is in a public subnet, but with a restricted security group. And this is for manual deployments. We're trying to show everyone what do you call it, a proper manual deployment is like. So Precious, do you understand why we gave backend the public subnet right now? Because we want to be able to access our APIs publicly so we can test. All right, great. All right, DB is available. Let's go and play with it. So we're going to have to install our Postgres client first. Read that code. That somewhere, yeah. So install Postgres client. Oh, that's broken. Connection. Nothing here. So let's install our Postgres client. So we have PSQL. Remember, okay, one more important thing. So this is quite important. You have to save this endpoint because it's needed. So there are some restrictions, and I hope that restrictions with the free accounts doesn't affect this particular. I don't think it's real because they're all in the same network. All right, so save your endpoints because it will be needed. So we have PSQL. Open your codes. Postgres. What's the DB name? DAXUP admin. Then we now have password. Where's that password? Now a password, then it's you now have your RDS endpoints. So you have your RDS endpoints. You now put in your ports 5432. Close the quotes. It's closed. Close the quotes. Then let's go into Postgres. Let's see. I think C select now. Apparently, I don't know how to spell select. All right. So we've established that backend server can actually reach our Postgres, right? So now we're going to be moving to deploying what do you call it? We're going to move to deployment. So let's see. You guys remember how what do I say here? So one thing we should always have in mind, so the code we're working with had particular flaws, right? Because it's supposed to be for teaching and understanding and all the rest of it. So whenever you get to understand works, when you're in work at work and all that, please do not accept codes that have DB creates, in them that run when your application comes on. I think this is complex for now, but just have in mind that your DB schema should be versioned. Have that in mind, yeah. Have that in mind. So now we're going to have to create our database. So let's create database text. So now we're going to have to clone our this thing. So let's first create SSH tgen hyphen t rc hyphen 4096 .c. All right, so we have our pub key. So the reason why we're doing this is we would have to link this with our GitHub. So remember how we use SSH. SSH is just much better way to connect. So that's what I'm doing. So you go to your GitHub. You go to your SSH and GPT keys. You create new SSH. Paste your, oops, I haven't copied that. Oh, where my phone? Okay. Please close your eyes. Thank you. Voila. All right, that has been created. Now we would have to test if there's an handshake, proper handshake. So that's with SSH, I think, capital letter T. Okay. So if it is GitLab, you do your GitLab. Yes. All right. I now $1, you successfully authenticated, but GitHub doesn't provide shell access. Always remember that. So let me clear. I like my terminal clean. So we've created what do you call it? We've created the table, yes. Okay, so now remember, why are we going to opt? Why do we think we are going to opt? Anybody? Can anybody remember what we said opt? The opt directories for? Can anybody remember? I'm not going to say anything until maybe somebody says no. Yeah, for third-party apps. What do you mean about DB create theme? Please, can you explain much better what you mean? Please, sir, it would be great to explain more on the DB create thing. Thank you. What do you mean? All right, so yeah, we're going to git clone. Let's get to the back end. Take the SSH. Oops. Voila. We already had an handshake now. Why? Okay, let's see what's going on here. This is weird. We already created one. No, but we already created an handshake now. Literally created an handshake. We got that message that says, maybe right here. Let me see. I'm getting yeah. Let's see. I'm fresh with sugar. Right, no problem. And this permission key. When you have public key permission denied, it usually is permissions. Let's see if we correct this permission. But this hasn't happened before. Wow, this is interesting. This is quite interesting. Hmm. This is not supposed to be happening. Okay. This is literally not supposed to be happening. Okay. I really want us to use that SSH. It's not supposed to be happening that way. I have no idea just yet why that is happening. No, I don't think so. I don't understand why that is happening. And I don't know if I set the remote repository to that, whether that will work. All right, let's see. The reason why I'm using sudo here is because we're in the opt directory and it is owned by root. That's why sudo is being used there. To grant the user privilege. Do you get? Okay, someone has answered you. Uh, wow, this SH thing is literally confusing, to be honest. Let's do this still. This is not necessary, but you can absolutely do it. All right. Why is it saying dubious ownership? I do not understand this, right? All right, let's quickly find out. Let me first use I need to find out why this is happening right here and right now. So sorry, we need to work this out. Anyways, let's continue with our deployment. That should. So the reason why we clone the app right now in this stage that we're in is because we want to impute the schema into but since we've been able to do that, I'm going to find the reason why the SSH isn't working, which is my preferred mode of working with Git and everything. So let's quickly okay. Let's quickly move on because of time. Okay, so we have the connection to Postgres already works. So we have to go to tax app. We're not using Postgres anymore. So this creates the table. Do you understand? In our schema. So if we check our schema, it creates the tables that the database, the backend would query and everything. So normally this is supposed to be done using Alembic migrations, which is backend Python for Python database migrations and everything. That's best practice. Yeah. In production, you have to use Alembic. Then you now use stuff like Alembic upgrade head and all the rest and all that. Yeah. All right. So our DB URL. Copy the DB URL because this is going to be needed. So I'm going to copy this and place it somewhere. I think I should export it even. All right. Okay, so we have that running. Now we're going to go into see how to properly deploy our Flask application with gUnicorn and systemd. Initially when we were working it, you see we just did run Python run. You understand? So now let's see. Okay. Let's see. That's why the permission is getting denied. Okay. Let's quickly correct that. Let's give the permission to Ubuntu. Now, let me see something. It should work now. Now it works. So now this has given a layer to another understanding that when you're creating your opt, make sure you give your Ubuntu access. Yeah. Change the owner. Your applications are not supposed to live in your home directory, but in your opt and maybe it can live somewhere else, but opt is actually best for third party. So let's continue. You remember what we did locally, so we would run the same thing. So Python 3, have we installed dependencies? I don't think we've installed our dependencies just yet. Just for safety, we need to install our dependencies. My brother, Linux, doesn't play at all. Just for safety, so we would not encounter some funny things. Are you guys still here? All right, great. I thought my network fluctuated. Okay, so after doing that, let's get back to this beautiful thing we want to create. Remember, we're not just going to do run py, whatever it is. Yeah. Same thing. Front end 2 changes just a little bit. So no. We're trying to create a virtual environment. So you get this is the same process as we did in local that we're following right here. This was available. So now we're going to upgrade PEEP. Then after that, we'll have PEEP to install our requirements. So it's always going to be install -r requirements. So since it's GUnicorn we're using, let's confirm we have GUnicorn. If not, we're going to have to put it. Okay, so let's what do we do here? We can install it directly, but I want us to actually follow due process. So what's going to be the GUnicorn? All these things here is for backend people to give, but we need GUnicorn. So let's not mess with backend code. Let me not tell you give you the perception that you guys can actually go into requirement.txt and all the rest of it stuff. If you need something, yeah, you reach out to your backend, yeah, and let them know, okay, please add, we need so and so. Backend will actually would have already added this, but we need GUnicorn. But we did not have this in our own code, but we need GUnicorn. So we're going to use pip to install it. All right, GUnicorn has been installed. So now we're going to have to create our M file. Right now we don't have any M file. You can see it right here. We don't have any M file. So we're going to have to create an M file. So how are we gonna do that? We could Vim or Nano. So first thing we're gonna do, Flask environment. It is production, no more development. Yeah. Then remember, I told you to save your database URL somewhere, right? You insert that. Then your J. Okay. In a moment, we need to confirm that. We need to confirm how the secret is being stored. So where is that supposed to be? It's not in run.py. It's gonna be in run.py. So now this is going to cause a lot of trouble. This right here has to be replaced. They had coded okay, so it's called secret key. What happened? I thought we saved this. Oh, okay, no, yeah. We've moved. So this is secret key. So for this secret key, we're going to have to create that stuff like JWT secrets that we did. So then we select this, get back into the env.py and paste the secret. All right. So now we're going to have to test this manually. Let's export the entire thing. We have sets -a source .env set plus a. What is going on again? Do you want it to be JWT secret key? Because this is weird. Let's see if this works. What? I have not encountered this before, so we are going to have to debug this together. Remember, Google is your best friend. And you can also use your AI to understand what is going on. Oh my God. So nobody picked it up. They didn't even have to go. Oh my God. Okay, so we need to change that back. That's the secret key. So after we set that up, we now do the gunicorn. This is the command. So 3 is telling, I think 3 is telling us the amount of workers that should be created and the port to bind to. Okay. Then we have run app. Hold your breath. What is going on? Okay. I forgot that again. This has changed. Then we have nano app. Need apply. Normally, you're going to tell your backend developers you do not want this type of thing, yeah? No hard coding of anything. Do you get? You let them know, yo, use Python dot env what do you call it? They will import that. They will import the Python dot env Python coders, Python engineers, yeah. What do they call that? Anybody coding Python, yeah? All right, so our application is up. You can see we have 3 workers as specified here. If we put 4, we have 4 workers. So let's see, let's call local host. We have to get back into this again because to test this is working, let's call local hosts 5000 slash API slash port slash login. Same found. All right, with that. Can you guys hear me? Table. Can you guys hear me? Guys, can you guys respond if you guys are actually hearing me so I know that I'm not seems the connection is gone. Okay, no wahala. All right, thank you. Okay, so we cancel this. Then let's now run this properly. Yeah, let's run this properly. So what we're going to do is we're going to create a system D service for out of this backend. So this is like real deployment, yeah. Like we said, it starts itself. It will start on what they call it on boot and it logs, right? So how do we create that? Okay, there's been some type of disconnection of bad going on. So I turn to I think my network is bad. So let me make somebody a co-host. We'll soon be done. So Ahmed Salman, I'm making a co-host, so so it doesn't cancel. Can you guys hear me, please? Identify if you guys can hear me. All right, thank you. All right, let's continue. So we got disconnected. And let's get back into where were we? All right, so we're saying we want to create the system D service, right? Else we go interrupted. So how do we create a system D service? We first create the file in the system D directory. So now etc system D system. Then we'll create tax app underscore backend dot service. All these things are very important. Yeah. So this is an initializing file. So please do not worry too much about the codes. So we have the units. We'll put a description. And description, we'll just name our tax app. We'll put after. It goes to the network, the target. And we have service. And the rest of it. So what this is saying is backend API after the network, the user is Ubuntu, the group is Ubuntu group, the working directory, which is wrong, is tax app underscore backend. The M file lives in tax app underscore backend, the env, and the G unicorn lives in also tax app backend. So I need to confirm properly where the M file is. All right, great. All right. Okay, so after doing that, we run the system. Since we were trying to start a new system, MD application, we have to re-exec and reload the daemon. So it's just to reset it and say, okay, well, I beg you, run this thing, yeah? So sudo system CTL. Can you imagine? It's not even giving me the chance to tab. Oh, I didn't spell system CTL well. Oh my God, it has hung again. Can you guys hear me? My network is messing up, so we might have to end this class. We've already passed our time, but I'm glad you guys are here with me. Okay, so that means this application did not start. Sorry. Oh, God, this network. That was the wrong name. So we've enabled it. Let me start it. Oh. So let's check why this isn't starting. It's loaded, it's enabled. Okay, let's get back in then. Our working directory is correct. Yeah, we have our Venv right here now. Why are you saying no such? We have our G unicorn right here. Well, that part is correct now. Is anybody catching what I'm not saying? Okay. Yeah, I've seen live debugging happening. I hope you guys are enjoying yourself. So if we do sudo start, man, this network should just give me a break. We'll soon be done. So it's active and running, right? We're good to go. Remember, initially, we didn't run this as systemd, right? So if we want to see this backend, what do you call it, logs, we can easily journal you use the -u, then we call the tax app. Then -f will make it live. So this is what is going on right now. Remember when we just did the G unicorn, it only showed us something similar to this, that 3 workers on with different process IDs and everything. So this, if it fails, it will restart. And if you notice this, it's multiple times, right? You're seeing this repeating itself over and over and all that. It's because it's continuously trying to restart. It's crashing because of the wrong name tag. Because of the wrong name tag. So if you still check, application is still running. So I believe we should stop here for today. Now next class we're going to talk about front-end deployment and also the CDN and DNS. Any questions before we call it a day? Yes, this thing. Okay. All right, Progressive, unmute.
All right. Can you hear me? A very good afternoon to
Yes, I
you.
can
All right.
hear
So we
you.
were talking before my network, I had a network outage. So I was like asking you for the people for those that are new in tech, what do you advise? How do you advise that we
Sorry, repeat
learn
that, please.
faster? So for those of us that are new into this, in tech entirely, how do you advise that we learn faster, that we catch up faster? What do you advise
You
us to
literally
do?
just continue training yourself.
Okay.
Go immerse yourself in projects. Immerse yourself. Don't just watch tutorials. Make sure you're working your hands, creating projects. Do you understand? That kind
Yes,
of
I
thing.
get you.
Challenge yourself.
Okay, secondly, you say we should be always ask Google. Can you give me an example of asking Google? Is it just you copy these things, then you ask Google, how can I solve this? Then you paste. I
Yes,
don't, can you just,
most people have already solved what it is that you are trying to um
to
whatever
do,
errors
to
it is
do?
that you're
Okay.
facing, right? So if you
Yes.
copy your error and you paste it on Google, Google is going to crawl the internet and find places. And now we even have something which is much more better. Yeah. We work with AI now. You have to integrate AI into your workflow. I'm not saying use AI for everything. Understand the concepts of what you're doing
You can do.
first,
Yeah.
because AI can hallucinate and you'll just be going in a loop. That's why I rarely say use AI at the beginning. If you don't know what you're looking at or looking for, yeah, don't use AI. Use Google. Google is already integrated to with AI, but the thing about Google is that the AI embedded on Google search right now would actually crawl the webs. It's actually giving you an output from crawling different websites. So it's going to give you what do you call it? Is it annotations and all the rest? It's going to show you exactly where it got the information from, and you can read up. Do you understand? Read on whatever it is that and get the knowledge. You understand?
Okay.
Just Google it.
Yes, I get you. I
Google is
get you.
supposed to be your best friend
Okay, let's
as a
let's
tech guy.
assume let's assume that I want to connect my local machine to my GitHub using SSH, but I don't know the commands. Can I use AI? Maybe AI can generate the commands for me. I already know what I want to do, but just that I don't know the commands. Is that
Yeah,
what
you
that's
can.
what
It's
you're trying to
possible.
say,
You
right?
can do that
Okay, all right.
as long as you're typing the command out by yourself. Oh.
Yes.
So you
Yes, I get
understand
you.
what it is that you're doing, because when it gets to interview time,
Hmm. I
if you are
understand.
just copying and pasting and you don't know what you're doing
Hmm.
no more,
No, I
it's at
understand
your
you.
own loss.
All right.
Yeah, good.
Thank you.
You're welcome.
Oh, God of mercy.
Is anybody else raising their hands? Okay. Ahmed, what's up? Unmute yourself. Let's call it a day.
Yeah, good afternoon. Sorry,
Good
I just want to ask about our last class. You know why we are deploying and building the app we did last on Wednesday? We refer back to the repo, your repo that we use for the backend, and the front end, right? I want to know why creating those apps. You created those requirements, JSON, tema. You created them yourself before we now try to integrate it with what we are trying to deploy.
I'm lost.
I don't know if you get my question.
I don't understand what you're asking.
Okay, now, you know what we did on Wednesday, right?
Yeah.
We try to integrate it from your repo, what you created, what you already.
What was I trying to integrate from my repo?
The tax app.
Integrating what sense? I don't understand what integrating.
No, not like. Yes, now you escape from your from the terminal. Not necessarily integration like that. You align both what you are trying to. You took what it's on the repo and that's what we deployed.
I took what was in the repo and did what?
And used to make the deployment what we built last week. On Wednesday.
Okay.
So I wanted to know if you did those repo or those the scripting and the code, you did it yourself, not in the class. Everything we are just trying to use what you have done from the GitHub to build the app.
Okay, so what's your question?
The question is, if I want to do something like that, just I want to create an app myself, I want to do something, I want to deploy, would I now? You didn't show
you get
us.
yourself a front-end engineer and a back-end engineer now.
So I have to get myself a front-end and a back-end engineer for me to do such.
Yes, sir.
Oh. So I can't just work that myself as a DevOps engineer.
You're gonna learn front-end and back-end now. You're asking if I wrote those codes myself.
I know you wrote it yourself, but you know that you are supposed to carry us along how the process.
No. That's not part of DevOps.
Okay.
That's absolutely not part of DevOps.
Oh.
I'm not supposed to show you how to create an app. I'm supposed to show you how to deploy an application. I'm supposed to show you how to maintain environments where applications live.
Yes, because yes, but my curiosity comes from where if I want to do the same thing, that's exactly what you did on Wednesday, or even what you did today, right? Those repo from the GitHub, you did it yourself. Would I be able to do it myself as a DevOps engineer?
Okay. See, that's out of the scope of DevOps. We are not front-end engineers. We combine front-end and back-end, build these applications. Then we deploy this application and make sure this application is live and reaching the end users. without any problem.
Okay.
Just like the example that I'm showing you, how to deploy the backend, how to create a VPC for networking. This is our own scope.
Okay, that's nice.
Do you understand?
I understand. So, but you now, but you wrote this in yourself. You didn't source it from the front end or any back end, did you? But you wrote this in yourself, right?
We create the environment.
Yes.
That is not supposed to be what they call it. That's not the scope of this course. Whether I wrote it or I didn't write it, concerned about its deployment, how the code comes about. So you can actually, just like, for example, now in this code that we're working with, in this code that we're working with, there was create app that was okay for local. When you get into your workplace and you're seeing your front end or back end, your back end engineer using create app in runtime of your app for your application, you would call them and, you understand, have them to understand that, we don't need to create this. We need DB migration versioning. That kind of thing comes up. That's a little bit more advanced than where we are right now. Do you understand? Like, okay, so you communicate. You are the pipe between development and operations. Do you understand? You're the one that actually makes the end users enjoy this app. Make sure the uptime is always up, highly available, resilient. Do you understand? That is our concern. Our concern is not totally with the code. The backend and front end are supposed to test it on their local and understand and know that, okay, this thing is working before they push it. Then we deploy it.
Absolutely. I get it now. Thank you very much. That was actually my concern. Thank you very much.
All right. You're deploying. All right, guys. Thank you very much. I had a swell time with you guys this Saturday. Enjoy the rest of your weekend. Bye.